In this video, we're going to talk about how to use the distance formula to find the distance between two coordinate points. So as a reminder, I've written the distance formula here, and it's d equals, where d is going to be the distance we want to solve for. On the right-hand side, we've got the square root of x sub 2 minus x sub 1, that quantity squared, and then added to that, y sub 2 minus y sub 1, that quantity squared. So if we want to find the distance between two coordinate points, all we have to do is say this point, for example, 4, -2, is going to be point number 1, and so we're going to call this x sub 1 and y sub 1, and then this is going to be point number 2, so we're going to call this x sub 2 and y sub 2. It doesn't matter which point you pick as point number 1 and which point you pick as point number 2, you just have to make sure that within a coordinate point you do x sub 1 and y sub 1, and for the other one you do x sub 2 and y sub 2. You would never want to do x sub 1 and y sub 2 in the same coordinate point, or x sub 2 and y sub 1 in another coordinate point. You just have to make sure that both of these you treat as 1 and both of these you treat as 2. Other than that, it doesn't matter which point is point number 1 and which is point number 2. Because you're squaring here in your formula, it'll work out either way. So now all we have to do is plug these into our distance formula. So we're going to say d is going to be equal to the square root of quantity x sub 2, which we know is -5, minus x sub 1, which we know is 4, squared, plus quantity y sub 2, 3, minus y sub 1, so minus a -2, and we square that, and this is all under our square root sign. And now we're just going to simplify. So a -5 minus a -4 is going to be a -9, so we have a -9 squared. 3 minus a -2, well, those both become positive, so we get 3 plus 2 is 5, so we'll get plus 5 squared. We'll put that under our square root sign, and then squaring both of these, -9 squared gives us a positive 81, 5 squared gives us a positive 25. 81 plus 25 is 106, so we get the square root of 106. And because there are no perfect squares which factor into 106, this is as simple as we can get it, and we can say that the distance between these 2 points, 4, -2 and -5, 3, is the square root of 106. So let's talk briefly about what that means. If we plot 4, -2 and -5, 3 on coordinate axes here, we have 4, -2 because we go over in the positive direction of the x-axis 4 units, and then down 2 because we have y is -2. So over to the right 4, down 2, and we get this point 4, -2. For -5, 3, we go in the negative direction of the x-axis and then the positive direction of the y-axis up to -5, 3. So when we're looking for the distance between these 2 points, really the distance we're looking for is this diagonal line here that connects the 2 points. That's what we're trying to find, and that's what we already know because we already solved for it. It's going to be the square root of 106. Now, the reason that that's true is because the distance formula is just an application of the Pythagorean theorem. Remember that the Pythagorean theorem tells us that a squared plus b squared is equal to c squared, where c squared is the hypotenuse of a right triangle. And of course, when we plot these points on our axes, we can make a right triangle out of them where the hypotenuse is something we already have, and then we draw our perfectly vertical and horizontal lines. This is our right angle here, our angle of 90 degrees. So we've got a right triangle, which means we can use the Pythagorean theorem, and that means that C is going to be the hypotenuse, and that A and B are going to be our opposite and adjacent sides here. Now, as you can see, if we want to find the length of A, all we have to do is take 3 here, and then subtract -2, because the length of this side starts at y equals 3 and ends at y equals -2. So the distance, the length of this side A, is 3 minus a -2, which of course is what we had here, 3 minus a -2, and the length becomes 5. And obviously that makes sense because the distance between the x-axis and this point is 3. So this distance right here is 3, which we know from this 3 here, and the distance right here is 2, which we know from this point here. 3 plus 2, of course, gives us 5, and that's what we found here when we said 3 minus a -2, and we got 5. If we want to find the length of B, we know that B starts at 4 and ends at -5, right? This is 4 here, and this is -5 here. So we do 4 minus a -5, or 4 plus 5. 4 plus 5 is 9, and of course that's what we found here. We got -9 because we did -5 minus 4, but remember, we always square it, so whether we square -9 or we square +9, we're always going to end up with positive 81, so this length makes sense. And again here, we know that the distance between the y-axis and this point here is 4 from this value, and we know that the distance between the y-axis and this point here is 5, which we know from this point. 5 plus 4 is 9, so we get 9 as the length of side B. So in other words, if we go back to our Pythagorean theorem here, we know that the length of side A is 5, so we get 5 squared. We know that the length of side B is 9, so plus 9 squared is going to be equal to c squared. We'll get 25 plus 81, we know is 106, equal to c squared. And then when we take the square root of both sides, we get c is equal to square root of 106. Remember, you could call this positive or negative square root of 106, but because we're dealing with an actual length, a negative length in physical space makes no sense at all, so we can just deal with the positive square root. So we get c equals square root of 106, which is what we found here. So just remember that you can always use this distance formula, but if you forget the formula, you can always draw your axes, plot your two coordinate points, just connect the points with a diagonal line that connects them directly like this, and then draw a right triangle with these two sides here to connect the points and draw your right angle here. Then just label your sides A, B, and C. Make sure C is the hypotenuse. And then you can use your Pythagorean theorem here. You just have to find out what the length of A is, what the length of B is, and then plug those into your Pythagorean theorem and solve for C, and you'll be able to find the distance between the points that way also. So that's how you use the distance formula to find the distance between two coordinate points.